Hey guys, so it's Tuesday and I'm obviously not there. I have meetings all day today, so I do apologize for being out. But same thing as yesterday, what I'm going to go through is just review today about isosceles and equilateral triangles. So again, you guys know the same deal as yesterday, just separate sheet of paper. We'll take the notes up front, and then you'll do the class activity on the back side and you'll turn that in. So the warm-up, again, pause it here, guys, try it out, and then we'll go through it. Okay, so for this warm-up, what we have to do, we have a lot going on, right? We have two triangles stacked. We have this exterior angle 145 being created. My job is to find the missing angle, this question mark over here. So how can I do that? Again, use all your vocab that you know. I know I have a straight line right here. Straight line is 180 degrees. So if I already have 145 taken up, so what is 180 minus 145? That's going to be 35 degrees. Okay. So now what? Where can I take it from there? Well, if I see this triangle, the very first triangle on the bottom here, how many degrees inside a triangle? 180. Triangle sum theorem. So that means that 95 plus 35 plus something is going to give me 180. Well, 95 plus the 35 will give me 130. How much more do I need for 180? That is going to be 50 degrees. Okay, so how does that help me? I'm slowly making my way up to this guy. Well, I have this 90-degree angle. I know it's 90 degrees because it has that little red square on the corner there. So 90 degrees, if I have 50 taken up, how much more do I need for 90? That's going to be a total of 40 degrees. And then we're going to use triangle sum theorem one more time. I have 70 plus 40 plus something else is 180. Well, 70 plus 40 is 110. How much more do I need for 180? This is going to equal 70 degrees. All right, guys, so let's jump into today's lesson. So again, equilateral and isosceles triangles. Make sure you guys title that up front of your notes. And again, the backside will be the class activity. Okay, so again, today's objective, students will be able to explain to a neighbor how to find a missing side or angle of an equilateral and an isosceles triangle using triangle properties. Again, all our definitions. What we're going to need today, triangle sum theory. Again, all the angles inside of a triangle add up to 180. Equilateral triangle. We know an equilateral triangle, all of my angles are equal. They're all congruent. And I also know all my sides are congruent. So those are the two properties that we need to know for equilateral triangle. Now, isosceles, it's only two. Only these two legs are congruent. Okay, and that means, again, if we go diagonally across, those angles are the only congruent angles in an isosceles triangle. And lastly, don't forget, perimeter of whatever shape is when you add up all its sides. It's the distance around a certain object. So what I want you guys to do, okay, we're talking about isosceles. These guys are isosceles triangles. Okay, now pick one, pause the video, try it out. We'll resume in a second. Okay, so let's go through this. This one is working with sides. So again, notice the values are on the outside over here. They're not within the triangle. So I'm working with the sides. And it says find the value of x. Well, I know I have an isosceles triangle because I only have two of the bottom angles here that are congruent. That means that if these angles are congruent, I go directly across. I know that these sides are also congruent. That means that they're equal. So in other words, I have 2x plus 31 is equal to 9. Well, I'm trying to solve for x, so how do I do that? Minus 31, minus 31. So what is 9 minus 31? That's going to be 22. Sorry, negative 22. I have 2x is equal to negative 22. Divide both sides by 2. I get x is equal to negative 11. And again, you're like wondering, can I get a negative answer? That's okay. I can get a negative answer for an x value, not degrees as of right now. And again, it was only asking for x, value of x. Make sure you guys can read that question, understand what it's asking. Now for this one, it says find the missing angles. And in this case, I have two of them. I have the one up here and the one down below. And again, I'm working with another isosceles. How do I know it's isosceles? These two little dashes here. It means that this side is congruent to this side. Again, I think there's a part where most of us mess up. Well, does that mean that this bottom one over here is also 53? No. Be very careful. Go diagonally across. Diagonally across. If this is 53, that means that this up here also has to be 53 degrees. How can I find the other missing angle? Well, triangle sum theorem says that all together adds up to give me 180. So if I have 53 plus another 53, that's 106 degrees. If I add these guys together, it's 106 degrees. So what's 180 minus 106 degrees? That is going to give me 74 degrees. So watch out with that, guys. Which angles are congruent, which sides are congruent on an isosceles. Okay. So guys, here's example number 2. So again, pause the video, try it out, and then resume in a second. All right. So here we have the following. It says, working with angles, can the following angle measures be part of an isosceles triangle? Remember, isosceles means that my two bottom angles are congruent, right? So I have to have two of the same plus a different angle. And in total, always, in order for it to be a triangle, it has to add up to 180. So I have two situations that can happen, okay? So here are my two situations. I can say that this is going to be 30, 30, 70, or I can say the other way around. I can say that this is 70, 70, 30. In order for this to be true, if I can make an isosceles triangle, these guys better add up to give me 180. Now here's the issue. Let's see. What is 70 plus 30? That's 100. 100 plus 30, that's 130 degrees in this guy. So does that add up to an 80? Nope, that's not possible for that, so it's not going to work out. What about this guy here? This is 30 plus 70, which is 100. 100 plus 70 is 170, close, but not 180 degrees. So no, it is impossible. I cannot. Can the following angles measures be part? We're going to say no, that is not going to work out. That's not going to fly this time around. So same deal happens over here. Again, if I'm working with an isosceles, I know that my bottom two base angles are congruent. So again, I have two situations that are happening here. I either have 45, 45, 90, or I have 90, 90, 45. And some of you guys are already seeing that right over here. For the one on the right, 90, 90, that's already a 180. If I add another 45, that's way above. So no, that's not even, I just passed 180 degrees. So what about the first situation? Well, what's 45 plus 45? That's 90, plus another 90, that is 180 degrees. So this one actually checks out. So we're going to say, can the following angle measures be part of an isosceles? We're going to say yes, at least one of these has to be true. In this case, this is the perfect combination. All right, example number 3. Now we're dealing with equilateral triangles. Oops, let me go back to that. Equilateral triangles, again, that means all sides and all angles are congruent. So pause the video here. Take a second. Okay, so find the value of x. So again, I have an equilateral triangle. How do I know that? Because all three angles are congruent. That means that all sides are also going to be congruent. Congruent means the same, so that just means that x plus 8 is going to be the same or equal to 11. Well, let's do minus 8. Minus 8 cancels out. I get x is equal to, what is that going to be? 3. And I messed up, didn't I? I'm special. I'm so special. Let me erase that because I put 8, not 18. Let's go back. I'm sorry, guys. X plus 18. Right, this side is equal to 11. I should be saying minus 18. Minus 18. I apologize for that. It's been a long, long day. X is equal to, what is 11 minus 18? That is going to be negative 7. And again, you're asking yourself, hey, can it be a negative answer for x? Yeah, of course. You don't have to plug it in, but the reason I caught myself was I was thinking, hey, if I plug in negative 7 here, plus 18, that's going to give me 11. And it actually makes sense, right? If it's an equilateral, if this is 11, this better be 11, and this also over here better be 11. So let's jump over here to the last one. Find the length of each side. So now it's asking me not just to find x, but I actually have to figure out how much does it measure. So in this case, it was 11, 11, right? Well, what the heck? I have 3 sides. Do I add them all up? What do I do here? Again, I know it's an equilateral triangle, means all angles are equal. all sides are equal, they are congruent. So it's honestly up to you. You can say that this 4x minus 27 is equal to 2x minus 9. You can say that 2x minus 9 is equal to 3x minus 18. Or you could have said 3x minus 18 is equal to 4x minus 27. It's completely up to you. The idea is that you understand that all three sides are congruent. So we're going to write some sort of equation that says that two of those pieces are congruent. I'm going to pick the easy. Let's go with these guys. Go with 2x minus 9 is equal to 3x minus 18. So again, we know those guys are equal to each other. You could have done it a different way. Absolutely, that's okay. Minus 2x, we get negative 9 is equal to 1x, or simply x, minus 18. Well, from here, what I have to do, I have to add 18, take it one step at a time. Some of you guys like to do a lot all at once, and that's where it gets confusing. 18 and a minus 9 gives us 9. 9 is equal to x, or x is equal to 9. But again, it says find the length, not just x. I need x. Okay, so I have to take that 9, and I'm going to have to substitute back in. So let's plug it into this guy right here. So it's 2 times 9 minus 9. What's 2 times 9? That's 18. 18 minus 9 is also 9. So that means that this length right here is 9. Now here's the secret to all of this. I have an equilateral triangle. If this is 9, guess what happens? This is also going to be 9. This is also going to be 9. Okay, all three sides measure 9. Now, 9 centimeters, inches, feet, whatever it may be, right? If you actually don't believe me, you can go ahead and plug in 9. 3 times 9, okay, is 27. 27 minus 18 is 9. If you don't believe me again, what's 4 times 9? That is 36. 36 minus 27 is going to be 9. All right, guys, so again, that was your notes. That should all be on the front side. Okay, I got one more. Perimeter. Calculate the perimeter for the following. So take a second, pause it here, we'll resume. All right, so I'm running out of time here. I'm trying to keep it under 15 minutes. So again, careful with this. This is not equilateral. Not all the sides are congruent. I know it's isosceles because only two of these sides. So again, if I go across and across, those are the guys that equal each other. This is 2x minus 12 is equal to 6. Let's solve that real quick. Plus 12, plus 12. 2x is equal to 18 divided by 2, x is equal to 9. Dang, it's a popular number today. So here's the thing. I need to find the perimeter, not x. The perimeter, again, is the distance all around. Well, I have to go back and substitute this in. So this is going to be 2 times 9 minus 12. Well, that's 18. 18 minus 12 is equal to 6. Hey, that actually makes sense. Check that out. This is 6. 6. What is this going to be? Let me plug in 9 over here. 9 plus 4 is equal to 13. Now, perimeter says I have to add up all sides. So I have to add up 6 plus the 6 plus the 13. Well, 6 plus 6 is 12. 12 plus 13 is going to give me 25. This has a perimeter of 25. Now, again, we don't see the units, right? Inches, centimeters, whatever it may be, but that is what we were looking for. So be careful. My biggest thing is always, what is the question asking? For perimeter. So it's great that you found x. It's great that you found that this side is 6 and this bottom side is 13, but it's asking for perimeter, which is the distance all around. So you have to add up all three sides of a triangle to get perimeter. All right, guys, here you have it. This is your class activity. Please flip that paper that you have over on the back. You have 5 problems today. All right. Number 1, find the value of x. Number 2, find the missing angle. So I'm looking for this piece here and this piece here. Number 3, can the following measures create an isosceles triangle? So can you actually create one based off of these values? Calculate the perimeter. That was like the last example we just did. And then lastly, find the value of x. All right, guys, have a great day. Make sure once you finish this, you turn it into the inbox. I'll see you guys tomorrow.